Evaluate the limit of x cubed minus 13x squared plus 28x plus 20, the entire quantity, over x minus 10 as x go to 10. This function or expression is not defined at x equal 10, so we cannot just simply plug 10 into the expression to evaluate the limit. However, if we plugged in 10, we notice that the numerator is 0 and the denominator is 0. And so we should be able to factor the numerator. Except that in this case, if we try to factor it using grouping, it will not work. One way to check to see if the numerator is factorable is to perform the synthetic division. Our wishful thinking hope that we would have a factor of x minus 10 in the numerator so that we can cancel out x minus 10. Since we want to have x minus 10 in the numerator as well, we're going to take x cubed minus 10x squared plus 28x plus 20 divided by x minus 10 using long division. But if we divide by a binomial of the form x minus k, then instead of performing long division, we can do a synthetic division. To perform synthetic division, we first write the coefficient of the polynomial. If there is a missing term such as x squared, then we would have to enter 0 for that term. In this case, all of the terms are present, starting with the term with degree 3. And so the dividends is 1x cubed, negative 13x squared, 28x, and the constant coefficient 20. For synthetic division, we only record the coefficients. And again, if this is x cubed plus 28x with negative 13x squared missing, we would have to put 0 in there for x squared. And then we draw a vertical bar on the left and we put the k in the binomial in the denominator. And so if this is x minus 10, k has to be positive 10, because for synthetic division, we divide by a factor of x minus k. If this was x plus 10, then we would have to put in negative 10 here on the left-hand side of the vertical bar. To set up synthetic division, we would skip a line and then draw another horizontal line. So we end up with 2 horizontal lines. Alright, first plug in the leading coefficient and put it under the second horizontal line. And then take this and multiply it with k. So 1 times 10, and then put the result in the next column between the two lines. 1 times 10 is 10. And then we add the numbers in that column. Negative 13 plus 10 is negative 3. And then we repeat. Take negative 3 times k, negative 3 times 10 is negative 30, and put the result in the next column, negative 30, and then add the numbers in that column. 28 plus negative 30 is negative 2, and then repeat. Negative 2 times 10 is negative 20, put negative 20 in the next column, and then add 20 plus negative 20 is 0. If the last number in the last row is 0, that means the division gives us the remainder of 0. If the remainder is 0, then we say that the division divides evenly into x minus 10. What that means is that we can write x cubed minus 13x squared plus 28x plus 20 as the product of x minus k, in this case is 10, times The number on the left-hand side of the remainder is the constant coefficient. The number on the left-hand side of the constant coefficient is the coefficient of x, and the number on the left-hand side of the coefficient of x is the coefficient of x squared. And so the quotient, when the expression is divided evenly, in this case, is x squared minus 3x minus 2. Thus, the limit at x go to 10 of x cubed minus 13x squared plus 28x plus 20 over x minus 10 is now the limit at x go to 10 of x minus 10 times x squared minus 3x minus 2 over x minus 10, and the x minus 10 factor canceled out, leaving us with the limit at x go to 10 of x squared minus 3x minus 2, which is a polynomial, so that we can evaluate the limit by simply plugging 10. 10 squared minus 3 times 10 minus 2, which is 100 minus 30 minus 2, so the answer is 68.